seems wrong that there's only one company that makes the game Monopoly. Anyways, that's what I'm thinking about. Okay, we're gonna finish Unit 6 today. We've already kind of covered the first half of Section 6.6. There was 2 videos for the first half of the section. We've got 1 more page to go, and then we'll be done with this unit. So awesome. Then we can move on to something new. Let's see how this works here. Nice and focused. That looks great. You'll notice that I have some of this already filled out because I think that makes the most sense to do that. So a couple reminders here, because now we are going to get into the part of the lesson where we discuss square root functions as the inverse of a quadratic function. And we just want to remind you what inverse means. So inverse means two functions are inverses if one function undoes whatever the other function does. So it does everything in reverse order and it just undoes whatever that function did. That also means that the x coordinate and the y coordinate get flipped when we go from a function to its inverse. So from an earlier lesson, if the point xy is on the graph of a function f of x, then the point yx is a point on the graph of the inverse. The x and the y coordinates just switch. Graphically, the graph of the inverse is a reflection of the function over the line y equals x. That's that diagonal line, and every point on the line y equals x has the same x coordinate as its y coordinate. And so those points are unaffected by an inverse, because if you take a point like 3, 3, you switch its x and y coordinates, it's still 3, 3. It's the same point, right? Additionally, it says the inverse only exists, and that really should say the inverse is a function if. So the inverse will also be a function if f of x is 1 to 1. And remember, 1 to 1 means that the graph crosses the horizontal line test. And let's just throw out there right from the beginning that the graph of a quadratic function is a parabola, and a parabola does not pass the horizontal line test because a horizontal line crosses through that parabola twice. Therefore, a quadratic function is not 1 to 1, and therefore its inverse is not a function. And that's going to be an issue that we're going to deal with here. Okay, so down below here, we have the function here that we used in the very beginning of this lesson. We've got a table of values here that we found that contain points that are on the graph of that function, and I have graphed those points here in green. I have also included a table of values that represent points on the inverse of this function, and I got these points by taking the x and the y coordinates and just flipping them. Okay, you can go through each of those and see how I took the x and the y coordinate and I just flipped them, and I plotted those points here in this red or purple graph. So the green graph is a square root function, and the red graph is its inverse, which is a quadratic function. And you'll notice, though, that I really only have half of the graph of that parabola. And that's because if I started with this square root function, the square root function is only half of a parabola as well. It's just half of a parabola that's laying on its side. So when I do its inverse, I only get half of a normal parabola. The other half would normally be over here. But we have to operate this way because we have to make sure that our graphs are 1 to 1 so that the inverse is a function. I wrote down the domain and the range for my square root function, and then the domain and the range of my inverse function. And the most important thing that I'd like you to notice here is that the domain of f of x became the range of the inverse, and the range of f of x became the domain of the inverse. This is something that will happen always with inverse functions. Without exception, the domain and the range always switch. We could put arrows on this side as well. Okay, now it wants us to find an equation for the inverse. So I'm going to rewrite the original function here, which was f of x equals the square root of x plus 2 plus 1. And this is something that we learned how to do earlier this year. So this is not new. I'm going to remind you that f of x is the y coordinate. And so I'm going to rewrite this function by replacing y for f of x. I haven't done the inverse now. I'm about to do the inverse right now. Inverse means that the x and the y are switched. And so I'm going to replace the y with an x. I'm going to replace that x with a y. Now at this point, I've really done the inverse. I switched the x and the y, that's the inverse step. In order to write this as a function though, I will want to resolve this equation for y. So I'm going to, excuse me, I'm going to subtract 1 from both sides. So this will become x minus 1, but I'm going to put that on the right side of the equation now. And then the square root of y plus 2 can go on the left. All right, and now I'm going to square both sides. If I square the left side here, that square root just goes away. And I just have y plus 2, and on the right, I'll just square the x minus 1. There we go. And the only thing I have left to do then is to just subtract that 2. Okay, because it was y plus 2, so I just subtracted the 2. And this is the equation for my inverse function. Now, if you want to multiply this all out and get the equation in standard form, you can certainly do that. If that's something you want to do, or if that's something you're asked to do, there's nothing wrong with leaving it in vertex form like this. This is a perfectly fine way to write the equation of a function. I do want to point out, though, that if somebody shows you this equation, you're going to assume that this represents an entire parabola, right? You're going to think this represents an entire parabola. But remember that this function is existing as the inverse of that square root function. When we do the inverse of a square root function, we're only going to get half of a parabola. So how do we indicate here that we only want to have half of this parabola and not the whole parabola? The way we do that is by using this domain. Or we can call that a constraint. And so what I do here is I just put a comma and I indicate my domain, which is that x has to be greater than or equal to 1. So we add that constraint on there to indicate that we're only going to use half of this parabola because we need this to be a one-to-one function. Because remember, when I do the inverse of the inverse, I have to be able to get the original function. This inverse thing is a cycle. It has to be able to go back and forth. Since I started with half a parabola, my inverse is also half a parabola, and I use a constraint to indicate that. Now, if we didn't have this graph, how are you going to know what that constraint is? Well, it's going to be the range of that original function, because the range becomes the domain. Okay, so we're halfway there. Let's see what this last page has for us. There's just a couple of problems here. We're given some square root functions. It wants us to graph the function, to graph the inverse, state the domain and range of the function and its inverse, and find the equation of the inverse function. Now, honestly, guys, I'm going to do this without graphing it because that's what we need to be able to do. I'm going to do it without graphing it, and then at the end, we'll come back and graph them. Okay, so first of all, I'm going to state the domain and the range for my g function. So for my domain of g, I'll take what's underneath the square root, which is x plus 5, and I need to make sure that that's never negative. So x plus 5 has to be greater than or equal to 0. That means x is greater than or equal to negative 5. So my domain is all numbers greater than or equal to negative 5. For the range of g, okay, let's see here. I know that the starting point of this graph starts on the origin and is shifted left 5 and up 1. So the starting point is negative 5, 1. Now with range, I'm thinking of y coordinates. So I'm really looking at this 1 here. Okay, I also know that since the 2 is positive, that my graph is going to open up and to the right as opposed to down and to the right. It's not going to do that. It's going to do this. So here's my point, negative 5, 1. All the other points are going to have y values bigger than that. So my range is going to be the numbers greater than or equal to 1. Okay, now watch what I'm going to do next here, because I can actually get the domain and the range of the inverse right away. See, it says domain and range of the function and the inverse. So let's find the domain of the inverse and the range of the inverse. And this is the easiest thing in the world, because we're just going to flip this domain and range. The domain of G becomes the range of the inverse, and the range of G becomes the domain of the inverse. They just flip like that. Okay, now we want to find the equation of the inverse, including the constraint. The constraint's just going to be that new domain. Okay, so let's rewrite G of x with the y there. So we'll have 2 square root of x plus 5 plus 1, and instead of saying that equals G of x, I'll say it equals y. I like putting the y on the right here because I'm about to switch the x and the y, and I'll do that right now. So 2 square root of y plus 5 plus 1 equals x. And you see how now I have the y on the left? I just like to have the y on the left-hand side. So I switch the x and the y because that's what we do with inverses. And now I'm just going to resolve this for y. So I'm going to subtract 1 equals x minus 1. Now I'm going to divide by 2, and there's lots of ways I could do that, and all those ways are correct. But here's how I'm going to do it. I'm going to take that x minus 1 and I'm going to multiply it by a half. You'll see why I do that here in the next step, where I square both sides. So squaring both sides gets rid of that square root. Now when I square this side, 1/2 squared is a 4th. And then when I square the x minus 1, I can just say it's x minus 1 squared. Easy enough. All I have to do now is subtract the 5. So I'll have 1/4 times x minus 1 squared minus 5, and that will be the equation for my inverse function. However, remember that we started off with a square root function, which is itself only half of a sideways parabola. And now we found the inverse, and we have this quadratic, which is supposed to be a whole parabola, but we only want to have half the parabola because we need to make sure that this is 1-to-1. And so we put a constraint on here, which is simply going to be our domain, which says that x has to be greater than or equal to 1. Okay, I'm going to go ahead and do the graphs of these real quick. So for the graph of G of x, my starting point is at -5, 1, which is right there. My a value is 2, so that means when I go right 1, instead of going up 1, I'll go up 2. Hold on a second, I did that wrong. No, I didn't. That is right. I'll go right 1 and then up 2. Okay, next I would go right 4, because remember we're doing the square root of our horizontal change, and 4 is an easy number to do the square root of. So I'll go right 4, 1, 2, 3, 4. The square root of 4 is 2, so normally I go up 2, but I'm doubling that vertical change. So I'll go right 4, and instead of going up 2, I'll go up 4. Next, I can try going right 9, which would take me to 4. The square root of 9 is 3, so normally I'd go up 3, but I'm doubling that. So this time I'm going to go up 6, which puts me right up there. And there's my graph for G of x. Now I'm going to tell you that we could get the graph of the inverse function even without this equation. Okay, we know how to graph this equation, and that's fine if you want to do it that way, but I want you to be able to get the inverse without needing the equation as well, and that's so easy. We'll just take each of the coordinates of these points and just flip them. So this point here is an x coordinate at -5, 1. I'll flip that and put a point at 1, -5. This point has coordinates -4, 3. I'll flip that and put a point at 3, -4. For this guy, instead of -1, 5, I'll go to 5, -1. And for this point here, that's at 4, 7, I'll flip that and go 7, 4. And there's the graph of my inverse, G inverse of X. And you should notice that this graph does match up with how we would graph this equation. The vertex at 1, -5, there it is. An A value of 1, which means I go right 2 up 1. Instead of right 2 up 4, I go right 2 up 1, which is 1/4 of the distance. So it all works out. Okay, let's do the same thing with this last function here. So we're going to do f of x, which is another square root function. I'm going to go ahead and get its domain and range right off the bat. For the domain of f, I'm going to take what's inside the square root, which is x plus 6. Say that has to stay greater than or equal to 0. That means x has to be greater than or equal to -6. So my domain is all numbers greater than or equal to -6. For the range of f, let's see, I know my starting point here. I'm going left 6 and down 3, so that would be -6, -3. The y-coordinate is -3. Because of the negative coefficient here, that means my graph is going to be the bottom half of the parabola. So these points are all going to have y-coordinates that are less than -3. So I'll say -∞ to -3. Okay, when we do the domain and range for the inverse, so the domain of f inverse and the range of f inverse, we simply switch this domain and range. The range of f becomes the domain of f inverse, and the domain of f becomes the range of f inverse. Okay, let's go ahead and find the equation for f inverse. I've got negative square root of x plus 6 minus 3 equals, instead of saying it equals f of x, I'll say it equals y, because it's the same thing. Now I'll switch the x and the y, so this x becomes a y, and this y becomes an x, and now I just have to get the y by itself. So I'm going to add 3 to both sides. X plus 3. Then I'm going to multiply both sides by a -1. So I'll have square root of y plus 6 equals. Now you can make this -x minus 3, and that's not necessarily wrong, but I'm just going to take that x plus 3 quantity and multiply it by a negative, because that's going to make this look a little bit more like we're used to with a quadratic function in vertex form. Okay, so now I'm going to square both sides, and so that gets rid of the square root here on the left. On the right, when I square this negative, it just becomes positive. See, that's awesome. That negative just kind of goes away, and I'll have x plus 3 quantity squared. Again, if you want to square it out, fine, but all I have left to do now is subtract the 6. So I'll have x plus 3 squared minus 6, and that is the equation for the inverse of f of x. Now remember that since this is the inverse of a square root function, then it needs to be 1-to-1, and this is not 1-to-1 because it's a parabola. So we need to put our constraint on here. And the constraint we already know what the domain is going to be for this inverse function, which is that x has to be less than or equal to -3. And so let's graph these things and kind of see how that plays out. So I'm going to graph my square root function. We already know the starting point is at -6, -3. We know that because of the negative, we are going to be graphing the bottom half of the parabola. So I'm going to move right 1 and down 1. I'm going to move right 4 and down 2. I'm going to move right 9 and down 3. And I don't think I can move right 16, so I'm going to call it quits there. And there is f of x. And now let's do the graph of the inverse, and I'm going to get the inverse by just switching the coordinates of these points that I plotted. So -6, -3 becomes -3, -6. -5, -4 becomes -4, -5. That's wrong, isn't it? Sorry, hold on a second. Oh. Oh, no, that's right. I had -5, -4, so I made that -4, -5. I'm good. Okay, I have a point here at -2, -5. So I'll switch that and go -5, -2. I have a point here at 3, -6, so I'll switch that and go -6, 3. And there are the points on my inverse. Notice that this graph does indeed look like half of a parabola. It's the left half because we started with the bottom half, right? So that kind of goes together there, that when we graph our inverse here, we get the left half of the parabola. Notice that I am only graphing points here that have x coordinates less than or equal to 3. Because that was our constraint. So you kind of see how that constraint does really play out there. Okay? All right, ladies and gentlemen, that brings us to the end of Unit 6. We are done, so you can finish up all the homework on that one, and I'll see you back here in Unit 7. Goodbye.